Have you ever wished you had a personal AI assistant that could truly understand you, remember your conversations, and proactively help you across all your devices? Not just a chatbot stuck in one app, but a persistent, intelligent agent that integrates seamlessly with your digital life? Today, we're diving deep into an incredible open-source project that aims to do just that, clawdbot, which has now evolved into moltbot. This isn't just another AI wrapper. It's a complete architectural rethink of what an AI agent can be. So, what makes moltbot so different? It all comes down to its unique modular three-layer architecture. At the very heart of the system is something called the gateway. Think of the gateway as the central nervous system of your AI. It's a persistent daemon, a program that runs continuously in the background on your local machine. By default, it operates on a local port, ensuring your data stays private. This gateway is the master coordinator. It manages your conversation sessions, routes messages, handles calls to various tools and skills, and most importantly, it manages the AIS memory. It exposes a secure WebSocket API, which is how everything else in the ecosystem connects and communicates. The second layer consists of channels. This is where moltbot connects to the outside world, to the apps you use every day. Channels are essentially adapters for platforms like WhatsApp, Telegram, Discord, Slack, and even iMessage. They are responsible for handling all inbound and outbound messages. When you send a message to your moltbot on Telegram, the Telegram channel adapter picks it up, packages it with the necessary context, and sends it over to the central gateway for processing. When the AI has a response, the gateway sends it back through the same channel to you. This design is what makes moltbot truly cross-platform. You can start a conversation on your laptop and seamlessly continue it on your phone via WhatsApp, because the gateway maintains the state of the entire conversation. The third and final layer is, of course, the large language models, or LMs. This is the reasoning engine, the brainpower behind the operation. Moltbot is designed to be model agnostic. This means you're not locked into a single provider. You can plug in powerful models like Claude or GPT using their API keys. Or, if you're a privacy enthusiast, you can even run local models directly on your machine using tools like Ollama. The gateway is what triggers the LLM. It takes your request, combines it with relevant information from its memory, and the available tools, and sends it to the chosen LLM for thinking and planning. Now let's talk about the key components that make this system operational: clients, nodes, and storage. Clients are the interfaces you use to interact with your AI agent. This could be a command line interface for developers, a dedicated Mac OS desktop app, or even a web chat interface. You use a client to send requests, like asking your agent a question or telling it to perform a task. When you connect a client, it performs a secure WebSocket handshake with the gateway, authenticating with a token to establish a trusted connection. Next up are nodes, and this is where things get really interesting. Nodes are what give moltbot its superpowers by allowing it to interact with the physical and digital world around it. A node can be your Mac, your iPhone, or even a headless server. These nodes expose specific capabilities to the gateway. For example, your phone could be a node that offers a camera capability, allowing the agent to take a picture. Your laptop could offer a screen recording capability. When a task requires local execution, the gateway can command a specific node to perform that action. This connection is also secured through a WebSocket, but with a special pairing and approval process, ensuring a random program can't just start controlling your devices. Another cool component is the canvas. The gateway can host a local web server that serves an editable HTML user interface. This is used for more complex agent workflows where the AI might need to show you something visually or require you to interact with a temporary user interface it has generated to complete a task. It's an internal dynamic workspace for the agent. But what about memory? This is often the biggest limitation of standard chatbots. Moltbot solves this with a robust, local-first memory system. It stores information in a dedicated folder on your computer, using simple, human-readable markdown files. There's a memory, MD file for long-term facts, daily journal files for conversational notes, and agents, MD file to define the agent's personality and skills, and a user, MD file for information about you. This system uses semantic retrieval, so the AI doesn't just scan for keywords. It understands the meaning behind your past conversations to pull up relevant context. It's persistent, private, and powerful. So let's walk through a typical connection flow. A client or a node sends a connect request to the gateway. This request is validated against a strict schema, and an authentication challenge is performed. Once successful, the gateway responds with a "Hello OK" message, which includes a snapshot of the system's health and which devices are currently present and connected. From then on, the gateway can emit events, like tick events for scheduled tasks or presence events when a new device comes online. When you send a request, say to an agent to plan a trip, the gateway receives it. It then triggers the LLM, which formulates a plan. This plan might involve using tools, which moltbot calls skills. Skills are defined in simple Markdown or TypeScript files and can do things like perform a web search, access local files, or even control your browser. The LLM executes this plan step by step, streaming the results back to you in real time. The system even uses idempotency keys to prevent duplicate actions if a request is accidentally sent twice. One of the most powerful features is proactivity. Moltbot agents run on a runtime called Lobster, which enables complex workflows with approval gates for security. A special heartbeat file allows the agent to be proactive. For example, you could configure it to check your calendar and give you a reminder every 30 minutes, or to monitor a website for changes. This isn't just a reactive chatbot. It's a proactive agent working for you in the background. It even supports multi-agent collaboration, where different specialized agents can work together on a complex task within a shared session. Getting started is surprisingly straightforward for a system this powerful. You can install it via npm, and a simple onboarding command helps you set up the gateway daemon to run automatically on your system. For security, especially if you want to access your agent from outside your home network, it's highly recommended to use a VPN like Tailscale or an SSH tunnel. This creates a secure, private network for your devices to communicate without exposing the gateway directly to the internet. While the system is designed with security in mind, it's important to be aware of risks like prompt injection. Running the agent in an isolated environment like a dedicated virtual machine is a good practice for advanced users. In conclusion, moltbot represents a fascinating leap forward in personal AI. Its persistent, local-first, and modular architecture solves many of the problems that limit current AI assistants. By giving the AI persistent memory, the ability to act proactively, and secure access to your devices through a central gateway, moltbot is paving the way for truly helpful and integrated AI agents. It's an open-source project, so you can check it out, contribute, and even build on top of it yourself. Thank you so much for watching this deep dive into moltbot. If you found this explanation helpful and are excited about the future of personal AI, be sure to hit that like button, subscribe to the channel, and ring the bell so you don't miss our next video. Let me know in the comments what you would use a proactive AI agent for. Thanks again, and see you in the next one.